Hi folks, this is College Algebra Take Home 4. We're asked to find a polynomial which has x equals plus or minus square root 5 as two of its zeros and touches the x-axis at -1, 0. So the key here, the result here we need to use is the factor theorem. And the factor theorem says that x equals c is a zero of a polynomial function p if and only if x minus c is a factor of p of x. So what does this tell us in this case? What do we know? Well, we know that x equals radical 5 is a zero. So that corresponds to a factor of x minus square root 5 in the polynomial. X equals negative square root 5 is a zero. So that corresponds to x minus it being a factor. But x minus negative square root 5, x plus square root 5. Finally, x equals -1 is a zero. How do we know that? Well, because -1 comma 0 is an x-intercept. So that means x minus it, which is x plus 1, has to be a factor as well. So the piece we haven't used yet is the description that the polynomial touches the x-axis at -1, 0. So that means geometrically at -1, depending on where the polynomial is coming from, it's just going to come down and bounce back. And we know from section 3.1 that this kind of behavior happens when the multiplicity of the zero is even. Remember, the multiplicity is going to be the factor that appears on, the exponent that appears on these factors. So it has to be even, so it has to be, say, 2. So putting this all together, I can start building a polynomial p of x. It's got to have an x minus square root 5 factor in it. It's got to have an x plus square root 5 factor in it. And it's got to have an even number of x plus 1 factors. So this polynomial will do the job. Let's start multiplying this out. We multiply the first two factors together. We have the difference of squares. So I've got x squared plus x square root 5 minus x square root 5 cancels out. Minus square root 5 times square root 5 minus 5. Now we multiply this out. And remember, folks, when in doubt, write it out. X plus 1 quantity squared is x plus 1 times x plus 1. So you have to use your distributive property here. Don't forget about that middle term. You get x squared plus 2x plus 1. Distribute the x squared through. Distribute the -5 through. And then we're all set for our final answer, x to the 4th plus 2x cubed minus 4x squared minus 10x minus 5. So this is one answer to the problem. You could take your polynomial and multiply it by 6. It would still fit the bill. You can take your polynomial and multiply it by the quantity x squared plus 4, and it would still fit the bill. Okay, so there are many answers to this. Here's one of them. That'll do it for Take Home 4.